Hello and welcome to zebracode.io. This is a free coding curriculum for high school students, and we are on Lesson 6. And in Lesson 6, we want to cover a couple of topics. One's modulus, that has to deal with the remainder, and the main topic is going to be branching. And branching is decision-making within a computer program, and it gives us different options. So let's focus first on modulus, and a modulus is denoted by this print sign operator, and it looks for the remainder. For example, 4 modulus 2, 4 divided by 2 is 2, and there is no remainder, so the answer would be 0. So it's looking again for the remainder. It's division and then focusing on the remainder. 14 divided by 3, well, the closest thing that will go in evenly is 3 times 4, which is 12, or the remainder would be 2. So in this case, 14 modulus 3 would have a remainder of 2, or modulus of 2. And 9 modulus 2, 9 divided by 2 is 4 with a remainder of 1, or similarly, you can take 2 multiplied by 4, that gives you 8. That's the closest to 9. Your remainder is 1, so the answer is remainder of 1. Let's open up an idle prompt here and just do these exact same things. 4 modulus 2, again, the remainder is going to be 0. That's the answer. We can see that. 14 modulus 3, again, if we divide it, the remainder is going to be 2 because 3 times 4 is 12, and the remainder is 2. 9 modulus 2, we're going to get a remainder of 1. Again, 9 divided by 2 would give us a remainder of 1. It's going to be 4 with a remainder of 1. The main focus of this lesson is going to be branching, and that's decision making. And for a branch, we must have if statement. If is required. Now, else if is optional, and you can have as many else is as you need. It can be a lot of them, or an infinite number of them, or almost an infinite number of them. And then for else, you can have only one else statement, or it's optional. You can have 0 of them. Another idea that we must be familiar with is equivalent or comparisons. And number 1 here is equal equal. That really is equivalent. If the two numbers are equivalent, or the two values are equivalent, that we use the double equal sign. Number 2 is the exclamation point and the equal sign. That means not equal to. Number 3 is greater than or equal to. Number 4 is less than or equal to. Number 5 is greater than. And number 6 is less than. So we're going to use these equivalents as part of our if statement, because if something is true, then we go into one path. For example, here's some sample code, and we're going to look at even numbers only, or we're trying to get to an even number only. We have our first statement. X is assigned the value of input, enter a positive integer. So the user enters a number, a positive integer, and we convert that in the next line to force it into an integer because it's a string. Now we can say if x modulus 2, so the number the user has entered, if it's evenly divisible by 2, well, then it's even. So we're using this exclamation point and equal sign. So if it's not equal to 0, then I need to add 1. Now, if I add 1, that makes the number even, and I can print the value out at the last line, print x. So go ahead and type this code out, execute it, run it, predict what you think you're going to get, edit it a little bit, and play with it. So here's another example of sample code. The first line prompts the user to enter a number, and then we take that number and convert it to a float. Now we start our if statement. If x is equivalent to 0.0, that's a float value for 0, then we're going to print equal to 0. Else if, we can have, again, it's optional, but we can have as many of these as we need. Else if x is greater than 0, then we're going to print greater than 0. Else, we can only have one else, or we can have 0, and it's optional. We can print x, or the number is less than 0. So here we have an if, else if, and else statement. We were required to have the if statement. The else if is optional, and the else is optional as well. Let's think about the execution flow of an if statement. Now we start with the if statement. If that's true, then we skip everything else. If that's not true, we go to the else if, and if that's true, we skip the else. But if nothing is true, if the if statement is false and all the else ifs are false, then we go to the default, which is the else. So that's how the execution of flow works with an if, else if, and else statement. Let's look at some additional sample code which illustrates this point further. The first line, we prompt the user to enter a test score, and the second line, we convert it to a float value. Now, if x is equivalent to 100, then we're going to print a perfect score, and we skip everything below it in the if, else if, and else statements. However, if the first part is not true, then we go to else if. If x is greater than 90, then we print an A. Now, if that's true, again, we skip everything below it. But if it's not true, then we go to else if again. Else if x is greater than 80, then we're going to print, in this case, it should be a B. And if that's true, then we skip everything below it. And then finally, if none of those are true, we go to the else statement. Finally, let's look at the idea of nesting different code blocks. So we have in our first line, we prompt the user to enter a positive integer greater than 3, and then we convert that to an integer. Now we're going to set a flag, and a flag is something we're going to assume that the number is prime, and then we're going to use a for loop for I in range 2 all the way up to almost up to x. It's actually up to x minus 1 because it doesn't include the end boundary. So if we're going to go through all of the numbers from 2 all the way up to the number minus 1, and if x modulus I, because I is going from 2 all the way up to x minus 1, if this is ever equal to true, that means it's divisible by that number, and obviously it can't be prime because a prime is only divisible by itself and the number 1. So in that case, if this is ever true, the modulus is 0, then is prime is set to false, and we use a break statement. A break statement exits us out of the for loop or any loop. So if we get through all the way from from 2 all the way up to x minus 1, and we've never hit this flag, well, then we can say if is prime, we're going to print the number, we're going to convert it to a string, it is prime, else it's not prime. So this is a couple of ideas I want to stress here is number one, we can have nested loops. We have a for loop, and within that we have an if statement, so we have these double indentation here. Then we have a flag, and our flag is prime. If that's ever set to true, then we're going to prompt that back to the user that the number is prime and display it accordingly. If it's not, then we display that prime is not. So with all of this sample code, you can cut and paste it because it's available in the resource slides, and you can cut and paste it, type the code in, execute the code, play with the code, edit the code, predict what it's going to be. That's the only way you're going to learn how to understand the sample code, is just to actually work with it. This is zebracode.io. Now let's go ahead and look at some demos on these same topics.